Okay, let's get started then. Okay, so 1.3 is lines. Okay, so in the first chapter, a lot of it is review. Here's more review. So I think everybody has sort of a geometric, intuitive understanding of what a line is. Right? You have some idea of what a line is, right? It extends in two directions, infinitely, and there's no bend to it, right? It's straight, right? There's some sort of straightness to it. Once you have a coordinate system, then you can start talking about, start putting some numbers on, adding some numbers to this. And so with a coordinate system, we can introduce other concepts, some concepts. Again, the first one is the notion of slope. The slope of a line. So, how do you define a slope of a line? You have some line, and you take 2 points on it. You say, okay, I've got these 2 points, x1, y1, x1, y1, x2, y2. And what we call the slope, right? Slope is defined to be the difference in the y values. It's usually denoted by an m slope, m, where m is y2 minus y1 over x2 minus x1. So it's the ratio of the change in the y values to the change in the x values. Right. So if I draw out that change is x1, y1, x2, y2, right? Then you subtract, right? You subtract you have y2 minus y1. That's often denoted with this delta. Delta is often used for change. Delta y, change in the y. And then here, you're going to get x2 minus x1. That's the change in the x. Delta x, the change in x. Okay. And notice that these numbers could be positive or negative, right? It's a signed change, right? So it's not just it's a signed change, right? It's not just this length here, but it's a signed length. Okay, so that's what people call the slope. First question: does it matter if we change the order? Suppose somebody says, "Well, what if I take these in different order? Does it matter? Do I still get the same slope?" Yeah. Why, Elise?
Because if they're both negative, then it's going to be positive.
Right. So, does it matter if we change the order? And the answer is no, right? Because if you change the order, you're just going to get y1 minus y2 over x1 minus x2. Right? But that's the same thing as negative y2 minus y1 over negative x2 minus x1, right? And you can cancel out the negative signs and get the same as you started off with. Right. So it doesn't matter what order. Question number 2, does it matter if we take different points, so 2 other points on the line, right? Do we get, and by does it matter, I mean, do we get the same you get the same thing for slope if we take two other points on the line, right? So if I take, instead of those two guys, suppose I take this guy and this guy, right? Are you still going to get the same thing? Okay. People are nodding. Why? Why do you get the same thing?
Because the ratios are the same.
Because the ratios are the same. Why are the ratios the same? Okay, so here's x1, y1, x2, y2. Let's call this thing x3, y3, x3, y3, x4, y4. So you're saying the ratios are going to be the same. Why are the ratios going to be the same? Think for 10 seconds. Why are the ratios going to be the same? Go ahead.
Going on like a little bit, but, like,
Sure.
Since like if you like the distance between like x like if you make like a right triangle
Okay.
with the first 2 points, and if you make a right triangle with the second 2 points, those triangles are similar.
Those triangles are similar. Yeah. So by similar triangles, you know that that this angle. So by geometry, you know that these angles are the same, right? Because these are perpendicular lines, right? These guys are perpendicular, right? And you've got a straight line here. So by geometry, you know that these things are at the same angle. Similarly, you know that these guys are the same angle. So these triangles are similar, right? Since you've got similar triangles, you know that the ratios of the side lengths are going to be the same. And of course, the signs, it doesn't matter the signs. I mean, the signs are the same, right? So it doesn't matter, right? So the ratio, we always get, no matter what 2 points we choose, this m, this thing, the slope, is the same. We get the same value. Okay. And this leads us to the sort of one of the formulas for a line. Formula for a line. Right. So you say, well, let's fix a point. So given a line, choose a point on that line. Okay. Choose a point on that line. Let's call it x0, y0. Then, for any xy on the line, we know that y minus y0 over x minus x0 is constant. Is constant, right? It's some fixed constant m. Same. Right? What we just said is that if you take any, you can take any xy here, and you're going to get m. Right? You're going to get the same value. Right? That's by our arguments over there. Okay. Right. So no matter what, y minus y0 over x minus x0 is going to be some constant m. Right. And this describes all the points on the line. Right. Right. And this you've seen before. Right. This is the in other words, y minus y0 equals m x minus x0. Right. This is the so-called point slope. The point slope form. Point slope form for a line. Okay, Okay, any questions? Right. Okay, so right. So yeah, I'm pretty sure without a doubt you've seen these sorts of formulas before. You've seen the point slope formula, you've seen the slope-intercept formula, you've seen the general formula, et cetera, et cetera. So I'm going to assume that you can find the equation of lines, find an equation for a line given, say, point and slope, slope and intercept, given 2 points on the line. So these are all things that you learned in, I don't know, junior high school or something, right? And that you can change from one form to the other. Right? If somebody gives you, so for example, here's a line in general form, negative 2x plus 4y minus 8 equals 0. Okay, and if I say, please change that to slope-intercept form. Take 10 seconds and write down the slope-intercept form. Okay, turn to somebody nearby. No, forget it. Somebody tell me the slope-intercept form. Allie? Y equals 1/2 x plus 2. Right. So you've changed it to the slope-intercept form, and you see that basically in each of these forms, different aspects are more obvious, right? So here, if it's in the slope-intercept form, that's great. You know what the slope is, and you know what the y-intercept is, right? If it's in this form, if it's in the point-slope form, then you know a point on the line, and you know the slope of the line, right, et cetera, et cetera. So these things are, depending on the problem, it might be better to switch from one form to the other. Okay, so let's just do some simple examples. If I give you this sort of thing. Suppose I say that the line passes through these points, a comma 0 and 0 comma b. Take 1 minute and write down the equation of the line. Okay, turn to somebody nearby and say, this is what I wrote down. Reese, you should really talk with somebody else. Okay. Okay. Who would like to say what they did? Who would like to say what they did? Nico, your hand is up. No, I know you're just scratching your head. I know you weren't raising your hand. Somebody who would like to say? Julia.
Okay. Y is equal to b over a x minus b.
B over a x minus b. Well, tell me how you think.
Well, b is technically negative, right? Because it's a negative y value.
B is a negative number, yeah. At least in this picture, B is a negative number. Although, you don't want to think, it's just B. B is B.
Okay. But if you treat it as just b, then because the slope's negative, then the slope's not negative.
Tell me what you think. So let's figure out the slope, right? The slope is going to be what? The slope's going to be what? The difference in y's, right? So y2 minus y1 over x2 minus x1, right? Or the other way, y1 minus y2 over x1 minus x2. Right. So either way, you're going to get negative b over a.
Yeah.
Okay. So that's the slope, and then what do you do with that?
Well, then the equation y equals negative b over a x, and then that's your y-intercept.
Okay, so you say, okay, I've got this. I have you've got the slope-intercept formula. Y equals mx plus b, right? So you're just going to use that. And you say y is going to be negative b over a x plus b, right? Let me go through the point-slope form. Just to make it clear where the slope-intercept. Suppose you forgot the slope-intercept formula, but at least we have this point-slope formula. Let me use the point-slope formula for a second. Say, okay, y minus. So I'm going to choose this point as my point. I have this point. I have this slope, right? So I'm going to use the points. I'm going to use the point-slope formula. Y minus y naught equals m x minus x naught. Y minus y naught equals m x minus x naught. And you see that we get the same thing as what Julia is just saying. Right. If you wanted to write it in points in slope-intercept form, you could switch it over to that form easily.
If you use the other point.
If you use the other point, you say, okay, I'm going to say y minus y naught equals equals m x minus x naught. Okay, and what do you get? Well, you get y equals negative b over a x minus b over a times negative a, right, which is b. So that's, it describes the same line as it should. Okay. One thing that they mention, no, just leave that off. It's not that important. Okay. Let's do a more complicated example. Yeah. One complicated problem. Okay, so you want what is the line parallel to that is having the same slope as this line, negative 2x plus 4y minus 8 equals 0, with x-intercept 4, right? In other words, it passes through 4, 0. It passes through 4, 0. So take 1 minute and work this out. Okay, turn to somebody nearby and if you have a clear cut, you can catch them. Yeah. They can't see it. But you have to move very slowly. You have to move like. Okay. Somebody want to tell me how to do it? Isaac?
You can use I think that's the point slope.
Point slope? Okay. Yep.
Formula.
Okay.
And you can, like the equation is y minus y1 is equal to, and then the slope, you're going to use the same slope as the other equation, which is 1/2.
Right. We already worked out the slope earlier. Right. So the
And
slope is going to be 1/2.
Mm-hmm.
So use great.
Then you can plug in 0 for x, and then, x is 4.
X is 4.
So 4 will be the x, and then y will have a 0.
Great.
So y is equal to, y minus 0 is equal to 1/2. You plug in for that 1 0, 1/2.
Great. Right, so you use the point slope formula. You say, well, look, I know what the slope is. I know what the slope is. The slope is 1/2. I know what a point on the line is. 4, 0 is a point, right? And so that gives it to me. What if I asked this? What if I wanted the line perpendicular to that line? Does anyone know the slope of the line perpendicular? Oh, you all do. Or many of you do. Cindy, what is it? -2, right? So it turns out that, so there's this theorem that says if two lines are perpendicular, two lines are perpendicular, then the product of the slopes is -1. So with slopes m1 and m2, respectively. Right. Then the product of the slopes is going to be -1. Okay, so why? Here's why. Why does that happen? Why does it turn out that the product of the slopes is -1? This is kind of interesting. In fact, it's interesting enough that once I gave a talk in Minnesota, and afterwards went out for pizza with the people who gave the talk, and one of them said, "Do you know the proof of the fact that the product of the slopes for perpendicular lines is -1?" And then he explained it to me at dinner. So here it is. Say, okay, suppose you have two perpendicular lines. Actually, let me make it a little bit more irregular. Suppose you have two perpendicular lines. Here they are. Okay. So they're perpendicular, and you're trying to convince somebody that the product of the slopes is -1. Is it obvious? I don't know if it's obvious, but in any case, here's one way of convincing the person. You say, well, I'm going to set up a coordinate system that's centered there. Okay. So set up your coordinate axes so that the origin lies at the intersection. Okay. Set up a coordinate system like that. Okay. And let's say that this one is m1, has slope m1, and slope m1 is positive, and this one has slope m2, and that thing is negative. Okay? And then you do something funny. You say, well, I'm going to walk out to 1 unit away from the origin. I'm going to walk on the x-axis one unit away from the origin, and I'm going to draw the vertical. I'm going to drop a perpendicular from here to here. Okay, so I make right. I have these guys who are perpendicular to each other to begin with, right? And I drop a perpendicular like this, so that it crosses the x-axis at a right angle. Okay. Tell me, what is this length? Tell me what this length is. Actually, talk to somebody nearby and say what you think about this length. At least you should sit closer. They seem to be nice people. They really are.
If you bring chocolate, I will bite.
Okay, so what's the answer? Kayla. Why do you say it's 1?
You went 1 unit over.
Okay, yeah, certainly this length is 1. Yeah.
And then because it is because it's perpendicular and it has it's an equilateral triangle.
Oh, you're hoping that it's an isosceles triangle.
Yes.
You're hoping it's an isosceles triangle. But look at my original picture. There's nothing that makes you're hoping, I think, that this is a 45-degree angle,
Yes.
right? But does it have to be a 45-degree angle? No. Right. There's nothing that guarantees that. Okay. So you don't know, right? It depends on the slope. If the slope were 1, then certainly, right? So if the slope of this line were 1, right? Then when you walk 1 unit over, you're going to go 1 unit up, right? That's what slope means. The ratio of the rise to the run, right? If the run is 1 and the slope is 1, then the rise is going to be 1 also, right? Okay, but the slope is m1. So, Jennifer,
You can use the Pythagorean theorem to find the length L, so then everything is square root of m1 squared plus m squared.
The square root of, so the slope, so this thing is not m1 length. The slope of it is m.
I think
Oh,
it
so
says
then
it
it's
goes
M.
over 1, it was,
It's
But when, what were you going to say?
I was gonna say,
It's m, it's going to be m1,
Yeah.
right? So since we've gone over one step, this length is going to be m1, right? So you don't need to use the Pythagorean theorem. No Pythagorean theorem. It's m1. Right? In other words, the coordinates of this point, right, are going to be 1, comma, m1. What are the coordinates of this point? One comma m2, right? Because for the same reason. Right? 1 comma m2. And so the length here is negative m2. Right? Remember, m2 is a negative number, so if I want the length, it's going to be negative m2. So no Pythagorean theorem was needed at that point, but in a second we're going to go crazy with the Pythagorean theorem. I bet you never thought you would ever do that. Okay. Yeah, I've never uttered such a phrase. In a moment, we're going to go crazy with the Pythagorean theorem. It just seems so ludicrous. But that's what we're going to do. Okay. So, okay. So now, so what is what's this length, Jennifer? What's this length here? Right, if this is 1 and this is m1, what's this length here?
it's 1 squared, the square root of 1 plus m squared.
The square root of 1 plus m1 squared. Right. And what's what's this length here? The square root of
Square root of 1 plus m2 squared.
m2 squared. Right. So we use the Pythagorean theorem once. We use the Pythagorean twice, and we're now going to use the Pythagorean theorem for the third time with the big triangle, right? Each of these little triangles was right. The big triangle is also a right triangle, right? So by repeated use of Pythagorean theorem, what you get is that a squared plus b squared equals c squared, right? So m1 minus m2 quantity squared. You have this length. This is a positive number. This is a positive number. You got them together. That's the total length. Right? That's the total length, and then you square. Okay. So what does that give you? That gives you that. So 2 plus m1 squared plus m2 squared is m1 squared minus 2m1 m2 plus m2 squared. The end. So you see that 2 equals negative 2 m1 m2. In other words, m1 m2 equals negative 1. A lot of pre-calculus is sort of just applications of the Pythagorean theorem. Okay, questions? Questions? Okay, there's one more topic in this section that's called least squares limits, or regression lines. And I don't like it being here, so I'm not going to talk too much about it, but I'll talk a little bit about it. So the idea is this. You have a bunch of data. Okay. And your data sort of shows that the two things involved, whatever they are, there's a linear relation between them, right? Roughly, you say, oh, look, there's some sort of linear relation between these two things, right? And you'd like to have a line that expresses that relationship. Okay. Now, no line is going to work. No line is going to work because your data is not perfectly aligned. Okay. But you'd like to choose some sort of a line that, so you want a line that somehow best approximates this data, your data, and to express the clearly, the apparently linear relationship between your two variables. Okay. And so there is a line that you can choose. Okay. There is a line that you can choose. It's called, the least squares line, or the regression line. And so here's how you choose it. Okay. You say, I'm going to take some line. So you take some line. You say, is this a good line or is this a bad line? How do you express the badness or the goodness of it mathematically? So what you do is you say, well, I'm going to take my line. Okay, so here are my points: x1, y1, x2, y2, x3, y3, da 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 da, right? Xn, yn. Okay. And what you do is at each x, you drop a perpendicular down to the line. So you drop the perpendicular down to the line, drop the perpendicular down the line, up to the line, up to the line, up to the line, up to the line, like this. Okay. So these things are basically how wrong your line is, right? How wrong your line is. Okay. And what you do is you take those lengths and you square them. Okay. So you square. So take the difference for each x sub I. Take the difference d sub I, which is going to be y sub I minus L at x sub I. Okay, so here's your line, y equals L of x. So you're going to get, this is going to be your d sub 1, this length here is going to be your d sub 2, d sub 3, blah, 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 right? D sub 1 is going to be y1 minus the L value at x1. So y1 minus the line's value there. So you get all these things, and then you sum the squares. You get d1 squared plus d2 squared plus dn squared. Okay, and square rooted. Take the square root. Okay, So sum all the errors, sum the squares of all the errors, and then take the square root of that, and that thing is called the L2 error. That thing is called the L2 error. Okay, so as a picture, what you do is you draw your line, you draw these, you measure these differences, and then you make squares and add up all the areas of these squares. Add up all the areas of these squares, and then take the square root of that. Okay, and that number that you get is called the L2 error. Okay, and so there is a way of finding the line with the smallest L2 error. Okay. There's a way of finding the line that will make the smallest sum of these squares. Okay. And that would be your least squares line. That would be your least squares line, or your regression line. Okay, and they give the formula for it in the book. But really, I think this topic should be introduced after you've had some calculus. So I don't want to talk about it too much. But this is important in science. In science, you often have some data. Like, I'd like to fit a regression line to my data. Okay. Now, what does that mean? It means that you're finding the line that is best in this sense. Okay. Any questions about that? Let me ask you a question. Why don't we just add the d's? Why don't we just add the d's and say, here I have some points. I'm just going to take the difference here, the difference here, the difference here, and the difference here, and I'm going to add them all together. Why would that be a bad thing to do? Vice.
Because without squaring and then rooting them, the negatives would cancel the positive.
Exactly. So you'd say, well, if you had a line that somehow had something like this. Suppose you had 2 points, right? Then this line would have 0 error. Right? If that were your error, then it would miss this sort of problem. You'd say, oh look, this line has 0 error, right? This line also has 0 error, right? And as you see, it's not that good an approximation to your data, right? Okay. So why not say take the absolute values of those distances and add them together? That would solve that problem, right? You can do it that way. And the answer is you can. It's perfectly fine to do that. That's a difference. That's not going to give you the least squares line. What we've just described is something called the little L1 error. Little L1 error. If you took D1 plus D2 plus Dn. So there's something a bit arbitrary about the regression line. You've chosen what it means to be good. So you've made an assumption about what it means to be good. Okay, that's it for today.